Algebra 2B, Credit 3, Lesson 18.2. Lesson 18.2, we're going to be getting into the graphs of tangent functions. We've already talked about the graphs of sine and cosine, at least about the effects on the graph. But here in Lesson 18.2, we're going to be working with tangent and working with the actual graphs. All right, so our first figure up here, let's kind of move this over so we're focused on that. Is for examples 1 and 2. Example number 1, they ask for the period of the function. Now notice the tangent function looks a little bit different, or maybe even a lot different than the sine and cosine function. As you can see, it kind of swoops in like this. And also it's between two dashed lines. And we remember that from when we dealt with rational functions. Those lines are asymptotes. These are lines that the graph will approach but never touch or cross. And the reason we have those asymptotes, you might remember there are certain values back when we did the unit circle for tangent that are undefined. And specifically, whenever the, remember that tangent is sine over cosine. So whenever the cosine coordinate or the x coordinate is 0 or the denominator is 0, tangent is undefined. So that asymptote represents those points where the graph is undefined. Now this is one period of a function. This keeps repeating. So if we wanted to, we could extend that either way, to the left or to the right, and we would have the same graph and then drawn in there with another asymptote and on into infinity. All right, for number 1, they asked for the period. And the period, you might recall from sine and cosine, is one cycle of the function. And with tangent, it's a little more defined because one cycle is what's between the asymptotes. And so we can see here we've got from 0 to 4 pi, well, negative 4 pi, but a distance of 4 pi this way. And so we have 4 pi and a distance of 4 pi this way. And so we add that up, 4 pi plus 4 pi is 8 pi. So our period here is 8 pi. Let's move that because we're going to need to do a little work down here. So the period is 8 pi. Again, 4 pi here and 4 pi over here. Now, for number 2, they want us to write the function for the graph. And for that, we're going to put it in the form of f of x equals a tangent of b. Now for that, this is for number 1. Let's go ahead and identify that. This is for number 2. So we need the values of a and b. Well, it turns out they're actually not too, they're pretty easy to find. So normally, without any transformations on the tangent function, this reference point here will be going through positive 1. Now remember, a is a vertical, tells us the vertical stretch or compression of the graph. And notice, instead of this point being here at 1, it's at 3. And so that tells us that a is going to be 3. Now for b, let's think about this for a second. For b, we know, remember that the period of the function is of a tangent function is pi over b. What I was going to say is, remember, for sine and cosine, remember it was 2 pi over b, but for tangent, without any transformations, it completes one cycle in a period of pi. It's just in our function here, this actually, with its transformations, had a period of 8 pi. Well, it turns out we could solve for b here. We're going to use p for period. Now, we're just showing this how we develop this formula. You're not going to have to actually do this. We multiply b to both sides, and we get bp equals pi. And we're solving for b, so we're going to divide p to both sides, and we get b equals pi over the period. And so in order to find b, we do pi over the period. Let's go ahead and get rid of that, just showing you how we develop that formula. So b is pi over the period. And the period we know is 8 pi. Well, let's go ahead and write it like that. And of course, the pi's cancel out, and we have a period, or it's not a period, but excuse me, a value for b of 1 over 8. So we know that a is 3 and b is 1 over 8. Now, that's not the answer. We're going to just substitute those numbers now in for a and b, and write our function. So we have f of x equals a, so a was 3, so 3 tangent of bx. What was b? 1/8, so 1/8 x, and that would be our final answer. So a and b are numbers that we need to identify. I believe that's there in your packet, so you need to fill that in. But your final answer is the function 3 tangent of 1/8 x. All right, so that's for 1 and 2. 3 and 4, we're doing a similar thing here. So let's go ahead and move over here and move some stuff out of the way there. There we go. All right, so same thing here. First thing they're going to ask us for, and let's give us some room here, is the period. Now notice on the x-axis here, we're not using pi. We're just using decimal numbers. And so, but the same concept applies here. So we're going from, the period is from one asymptote to the other. That's one cycle of the function. So from 0, we go 0 to -2. But again, we're just concerned about distance. So we don't look at the, make this clearer. We don't look at the -2. This is just a distance of 2. In fact, actually, so we can see that better. Let's write it over here. So a distance of 2, and we have another distance of 2 here. So 2 and 2, so we add that up, and the period is 4. And so the period for, and this is our example for number 3, we have a period of 4. All right, so now, just like the last one, for problem 4, our example for number 4, we need to identify A and B. So once again, we're just going to use those reference points. Again, remember that normally the reference point without any transformations is at 1. Notice here it's at 1.5. So the value of A here is 1.5. Now, something else to mention too, the normal, or let's say without any transformations, tangent function going from left to right starts low and then ends high. If it does the reverse, where it starts high and then ends low, we know that A is negative. And so, because it was reflected over the x-axis, in other words, this went up to here, and then this went down to here. So again, because the function's reverse, starting high and ending low, that tells us that A is negative. So we found the value of A, and then just made it negative. All right, now B, once again, remember the formula for B. We're not going to develop that again. It's just pi over the period. The period is 4, so the value for B is pi over 4. So we have our values now for A and for B. And now we're just going to substitute those into the function. We have f of x equals, A is first, so -1.5 tangent of bx, so pi over 4. Make that look a little more clear. Pi over 4x. And so that's our answer. F of x equals -1.5 tangent of pi over 4x. And that's what you do for number 4. And that is it for the examples for lesson 18.2. So we'll kind of end with everything there on the screen. You can pause that and look at that again if you need to. So again, and as we always say, pause and rewind the videos. You're going to do great with the work. Just take your time with it, study the examples, and rewatch as needed. And until the next video, that's it for now. Take care and God bless.